Hi, I'm Ms. Milkowski, the mathematician, and today we are going to talk about sequences. So, if we are given the second and fifth term in an arithmetic sequence, write an explicit rule for the sequence and find the ninth term. Okay, so we know our second term is 6 and we know our fifth term is 18. And what is our goal? What do we want to do? We want to write an explicit rule. Ooh. Oh goodness, that marker's dead. Let's try this green one. We are going to write an explicit rule and we want to find the ninth term. Okay, so we should probably find the explicit rule first, or write an explicit rule first, because then once we have that, we can plug in 9 for n and solve for the ninth term, the value of the ninth term. Okay, so first thing I want to think about is when you have a arithmetic sequence, what we know is, so I'm just going to write out, we're just going to go to 5 here. So we've got 1, 2, 3, 4, 5. Okay, so we know the second term is 6 and the fifth term is 18. So in an arithmetic sequence, to get the next term, we add what's called the common difference to the previous term. Okay, so we add a common difference, the common difference to get this would be the third term. We add the common difference again to get the fourth term, and we add the common difference a third time to get the fifth term. So remember, D is your common difference. Okay? And that is what we add to the previous term to get the next term. Okay? So let's think about this. So, think about, I'm just going to do a quick example that I'll then erase. So think about like a sequence 2, 4, 6, 8, 10, So to go from here to here, we added 2. And to go from here to here, we added 2. So you add 2 to 2, you get 4. Add 2 again, you get 6. Add 2 again, you get 8. Okay, so in this case, your common difference would be 2. Okay, so that's what the common difference is. You just add it to the previous term to get the next term. So here, the problem is we don't have the two terms. Like if 18 had been here, it would have been easy. Oh, the common difference is 12, and then we can move on from there, right? But we have to do a little bit more work. So what I want you to do is kind of think about it. And there's a couple ways to think about it, okay? So this is one way. So to get this next term, okay, we're adding D. And then to get the term after that, we add D again. And then to get the term after that, we add D again, okay? So we started with 6. We added D 1, 2, 3 times. And that's going to give us 18. You see that? So we said, now, I understand for some people that I may have skipped some steps. So this is what I want you to think about. Let's say I wrote it out again, okay? 1, 2, 3, 4, 5. Okay, so again, this is our a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Okay, so this was 6. So then this is going to be 6 plus D. Okay, then the fourth term is going to be the previous term, which is 6 plus D. Okay, and then plus D again. Okay, and then the fifth term is going to be here, I'll even use a different color. The fifth term is going to be the fourth term. Okay, which is 6 plus D plus D, okay? And then we are going to add D again. Okay, so in this case, we have 6 plus D plus D plus D, and that's going to equal the fifth term. Okay, so that's 6 plus 3D, and it equals the fifth term, which we were told was 18, so we can just plug it in. Okay? So that's kind of maybe a better visual in case you didn't follow that if I skipped too many steps. So here we go, writing out every step. And let me just show you one other way to think about it, because we know everybody's mind is different. Everybody likes to organize math problems differently. And I want to stress that there is absolutely nothing wrong with that. If you don't, obviously if you're breaking math rules, you can't do that. But like you can't say 2 plus 3 equals 12 or something. But if you're not breaking any math rules, you run with it. All right, so here's another way. We know that a sub 2, okay, the second term is 6. We're adding a common difference. So a3 is 6 plus d. Then a4 is going to be the previous term, 6 plus d, and then plus d again. Okay, so 6 plus d. Then we bring that down there. And then the fifth term is going to be this. Okay, so 6 plus d plus d. plus D. Now I understand that looks basically the same as the last one, except it's vertical and I don't have the slots, if you will, for the terms. But I also think we also wrote a sub 2, a sub 3, a sub 4 vertically, and I just think some students kind of like, you know what I mean? For them, it just, I get it. I get why this might make more sense or be a better visual for you, okay? So I'm going to erase that so we can focus on what we have, okay? Which is that 6 plus 3D equals 18. All right, whoops, I'll pick that up in a second. So if we want to solve for the common difference, we just subtract 6 from both sides. We get 3D equals 12, okay? Then we divide by 3, we get D equals 4. So we know our common difference is 4. Now, there's, we can figure out the explicit rule by plugging in a formula, which is fine if that's what you want to do. But we can also just kind of do it intuitively by saying, well, this is now no longer D, okay? This is, let me get this. This is 4, okay? So I can erase all these D's, and instead of writing D, I can write 4. Okay? And so then I could easily fill in what every term is. So 6 plus 4 is 10, 10 plus 4 is 14, and then to 18. Now, if I want to write the explicit rule, we know kind of the way to write the explicit rule is a sub n equals a sub 1 plus d times n minus 1. Okay? So in order to write the explicit rule, we need to know what a sub 1 is. We know what d is, and then n stays as n. So we need to find a sub 1. Well, if this is the second term, and this is the third term, and this is the fourth term, and this is the fifth term, this is the first term. So in order to get from the first term to 6, we had to add the common difference, which is 4. So if we want to go backwards, we're subtracting 4. So this is just going to be 2. Okay, so that's a way to think of it intuitively. If we want to go this direction, we're adding 4. If we want to go this direction, we're subtracting 4. But if you really kind of want to see it written out, what we can say is, well, a sub 1 plus that common difference equals a sub 2. Okay, so a sub 1 plus that common difference, which we know is 4, is going to equal a sub 2, which we know is 6. Subtract 4 from both sides, hence subtract 4. And we get a sub 1 equals 2. Perfect. Okay, so now that we know that a sub 1 is 2, we have every single piece that we need to write the explicit rule. Okay, so let's see where I can do this. I think I'll erase this just so I have more room. Maybe I'll put it in green. Okay, so here's our formula for explicit rule. We know that a sub 1 equals 2, the first term is 2, and d is 4. So then we just plug it in. We plug this in for D, we plug this in for A sub 1. So A sub n equals 2 plus 4 times n minus 1. Okay? Perfect. Now, some teachers are going to want you to simplify, and sometimes saying the explicit rule literally means I want it to be in simplified form. Okay, so check, obviously your teacher's giving the test, your teacher's the one that makes the rules. So you have to check with them about which way they want it. I personally would accept it both ways, I think. If you do simplify it out, it just becomes easier when you start plugging things in. So that's why a lot of teachers, allow it that way as well, or want it that way. Okay, so I'm gonna box this just so that we know this could be one way to write it. Then I'm gonna rewrite it again so we can simplify it out. Okay. So then we're just going to distribute the 4, and always draw those distribution lines no matter how advanced you think you are, because I'm telling you, even I've made mistakes because I forgot to draw a distribution line and I forgot to distribute something. A sub n equals 2 plus 4 times n is 4n. 4 times negative 1 is negative 4. So then we get a sub n equals, and then 2 plus negative 4 is going to be negative 2. So we'll start with the 4n minus 2. Boom. Awesome. So now we know that our explicit rule is just a sub n equals 4n minus 2. And if we want to quickly check, we plug in 1, we get 2. Good. We plug in 2 for the second term. That's going to be 8 minus 2 is 6. Good. We plug in 3 for the third term. That's 12 minus 2. That's 10. Perfect. 4, 16. 16 minus 2 is 14. Good. And 5, 20. 20 minus 2 is 18. So we know we did it right. And I always recommend you do check that, okay? because that'd be the worst if you messed up on the explicit rule and then you got the 9th term, you'd get it wrong because you'd have the wrong rule. All right, so let's try to do the 9th term. So let me see what color I can use here. I'll use the black over here. Or I don't know, maybe I'll use the brown. Okay. Sometimes red and orange are hard to read. Okay, so now we want the 9th term. Okay. So that means all we're going to do is we're going to take our explicit rule, a sub n equals 4n minus 2, okay? And we're going to say, I want the 9th term, so in this case, n equals 9, okay? So the 9th term equals 4 times 9 minus 2, okay? So 4 times 9 is 36, okay? So that's a sub 9. And then 36 minus 2 is 34. Perfect. So we are done. We got our explicit rule. We found our 9th term. We are all set. So good job. Hey everyone, I'm Ms. Milkowski, the mathematician, and I hope you found that last video helpful. If you have any questions or if there are any topics you'd like to see me cover in future videos, definitely let me know in the comments below. Thank you again for watching. I hope you have a wonderful day, and I'm going to leave you with the most important piece of advice I can give you, which is when you're doing mathematics, always ask why.